Hi guys, today we're going to talk about mean absolute deviation. And the I can statements we're working on are, I can find and interpret measures of center and measures of variation. Well, the mean absolute deviation is a measure of variation. So we're going to be focusing on this portion of the I can statement. And for the second I can statement, I can informally assess the degree of visual overlap of two numerical data distributions, and we're going to do that with dot plots with similar variabilities and measuring the difference between the centers by expressing it as a multiple of a measure of variability. And the measure of variability, again, that we're going to be talking about is the mean absolute deviation, and it has to do with one of the measures of center that we've already talked about, the mean. So what is mean absolute deviation? Well, let's break it down and look at each word in this term. The mean is the average, where I add up all the data items and divide by the total number of data items I have. Absolute is referring to absolute value, but in this case, we're not going to be looking at the absolute value of a number and its distance from 0. In this case, we're going to be looking at each data set, each item in the data set, and its distance from the mean. And the deviation is just how does that differ from our original mean. The mean absolute deviation tells us how consistent a data set is, and it also is the average distance between each data value and the mean. So how do I find the mean absolute deviation? Let's look at some data. The table we have here shows the number of contacts 8 friends have stored in each of their cell phones. Let's find the mean absolute deviation of this data. There are 3 simple steps that I can take to find the mean absolute deviation. First, I need to find the mean of the data. So I would take all of those 8 data items, add them up, and divide by 8, and I would get 56. So 56 contacts is the average or mean for this data set. Step 2, once I've found the mean, I then need to go back and find the distance between each data set and the mean. Or sorry, it should be each data item and the mean. So let's look at that on a dot plot. We had one friend that had 68 contacts, 52, 54, 55, 58, 59, 60, and 62. And since my mean was 56, it was not part of the data set, but sometimes it might be. But in this case, it wasn't. So now I need to find the distance between each of my 8 data items and the mean. So as you see, from 56, I need to go 1 place to get to 55, 2 places to get to 54, 4 places to get to 52, and 8 places to get to 48. Now if I look at the right side, I need to go 2 places, or it has a distance of 2 on the number line, to get to 58, 3 to get to 59, 4 to get to 60, and 6 to get to 62. So now I'm going to take these distances, these values, and find the mean of those values. And this is very similar to finding the absolute value of each data item and the mean. So it's very similar to absolute value because we're measuring a distance. The third step then would be to find the mean of those differences. So again, I take my 8 distances from the mean and I add them, and then I'm going to divide by 8 because there are 8 distances to find 3 7/75, and that is the mean absolute deviation of this data set. Now it's your turn. This table shows the maximum speeds of 8 roller coasters at an amusement park. Find the mean absolute deviation of the data set. Then describe what the mean absolute deviation represents. Now in the last problem, this mean absolute deviation tells us that each data item is about 3 75/100 units away from 56. So, when you're doing this problem, find the mean absolute deviation of this data set, then describe what the mean absolute deviation represents. Okay, let's look at what you wrote. Step 1, you should have found the mean. Adding up those 8 data items, then dividing by 8 to get 64. So the mean is 64 miles per hour. Next, you needed to find the absolute value of the differences between each value in the data set and the mean. So you would take your mean of 64 and figure out how far away that was from 58, 88, 40, 60, 72, 66, 80, and 48. Finally, you take all of those differences, or you average the absolute values of the differences between each value in the data set and the mean to get 12 and 5/10, or 12 and a half. And that represents about 12 and that all the data falls in about 12 and a half miles per hour. So the mean absolute deviation is 12 and a half. This means the average distance each data value is from the mean is 12 and a half miles per hour. So why do I need to know the mean absolute deviation? Well, you can use it to compare data sets. A data set with a smaller mean absolute deviation has data values that are closer to the mean than a set with a greater mean absolute deviation. Let's look at this problem. Here we have the top 5 salaries and the bottom 5 salaries for the 2010 New York Yankees. These salaries are in millions of dollars and are rounded to the nearest hundredth. My first step is to find the mean absolute deviation of both sets individually. And when I do that, I would learn that the top 5, the mean absolute deviation, is about 4 and 1900 million dollars. The bottom set has a mean absolute deviation of 1/100th of a million dollars, about. So what does this tell us? Well, since the mean absolute deviation of the bottom 5 salaries is much smaller than the top 5, we can tell that the data for the bottom 5 salaries are closer together than the top 5. This means that there's less likely to be an outlier in this set as well. Now it's your turn. This table shows the running time in minutes for 2 kinds of movies. Find the mean absolute deviation for each data set. Then round to the nearest hundredth. Then write a few sentences, 1 or 2 max, comparing the variations. Pause the video now and complete this problem. When you're done, hit play. Okay, here's another problem for you. Below are the heights of the players on the University of Maryland women's basketball team for the 2012-2013 season and the heights of the players on the women's field hockey team for the 2012 season. Just to note, it is typical for a women's field hockey team to have a lot more players than a women's basketball team. So if you're wondering why there's so many different players on the field hockey versus basketball, that's why. I've also included a double dot plot of the heights of the women on the field hockey team and the women on the basketball team. We're going to take this data and answer a couple questions about it. Pause the video now and answer A and B. This is it for this lesson. When you have finished answering these questions, don't forget to WSQ in your notes and make sure your question is one that you have or one that someone else in the class may have. You can go back and watch this video as many times as you need to, or just portions of it.